view of 2018. All right. People enter the line. Notice what they do is they give you a function that is the rate that people entering in the line, and that's for the first 300 seconds. And then after 300 seconds, nobody's entering in the line. As people get on the escalator, they exit the line at a constant rate of 0.7 person per second, and there are 20 people in the line at time equals 0. Notice there's 3 things they tell you. They give you the rate of adding, the rate of subtracting, and initial value. Whenever you have an accumulation problem, you look for, all right, are we adding, subtracting, and what's my initial value? Got it? The biggest thing to overlook is that initial value, right? Because you've got to tell where you start. All right, how many people enter the line during the time 0 to 300? What do you do?
Plug in.
So we've already plugged this into Y1, right? That's a given. That's already plugged into Y1. If that's a rate, and I want to know how many people, what do I need to do?
Plug in 300, plug in 0, subtract.
No. How do you find the total amount if you're given a rate?
Integral.
You take the integral. Everybody understand that? Big, big, big deal, right? This is the common thing. That's what happened. That was what happened in 2019. So for part A, we're going to take the integral from, they want to know from 0 to 300 of whatever that function is. So one thing I do want to make sure when you write something down, when you write R of t, I don't think they'll count off if you leave off the dt, don't put y1 here. Right? Put whatever function they're using. Does everybody understand that? I know that you're using y1 in your calculator, right? But don't put y1 here. The function's name is R of t. So has everybody typed it in? I already did it. What'd you get? Here, I'll hit pause so you don't have to. So that equaled to 70, right? All right. During the time interval 0 to 300, there are always people in line for the escalator. How many people are in line at time 300? All right. So this is a common question. Anytime you have a rate problem, they give you the rate that stuff's being added, they give you the rate that stuff's leaving, and they give you initial condition, right? And you're going to have to use all of that because that's what they need for part B. Does everybody understand that?
Yep.
So we need to know, right? So let's sort of write down all the parts. How many people do we start with? 20. Okay. All right. How many people were added? 270. We already did this, right? I'm going to go ahead and put the integral from 0 to 300 of R of t, but we know that number is 270. And then how many people left?
7%.
So we're going to subtract, right? Now there's 2 ways to think of this. One is, if they tell us the rate, like this is a rate of 0.7 person per second, then that's going to be the integral from 0 to 300 of 0.7. Because this is a rate, right? Anytime you integrate a rate, that tells you how much. Anytime you integrate a rate, that tells you how much.
Or you can just multiply 0.7.
Yeah, or you just multiply 0.7 times
People
300.
per second times second equals
Yeah.
people.
Right. But I'm really emphasizing the fact, do you see how we set this up where you started with something, you added, and you took away? So honestly, you don't really need calculus at this point because this is going to be 20 plus, we know this number is 270, and this is going to be minus 0.7 times 300. And so we get a nice number. Everybody get 80? Right? And just so you know, in the rubric, they have something that you have to remember the initial condition. Like they actually point out if you forget the 20, then you lose a point. Or you get 1 point for making sure you have the initial condition. Are we okay? I desperately wanted to make sure I talked about A and B because these are incredibly common, right? Actually, C and D are pretty common too. For T greater than 300, what is the first time there are no people in line for the escalator, right? So, they have to tweak things every year, right? And so in this, their tweak this year was, all right, we're going to add for the first 300 seconds, and then we're not adding anymore, but we're still taking people out, right? So at 300 seconds, how many people are at, so I'm going to have to erase this. What?
There are 80. There
Oh.
are 80 people in line for 300.
So at 300 seconds, there are 80 people, right? Now, what happens? How do you find out if people are still leaving? What rate are they leaving?
0.7, so 0.7x minus 8 equals 0.
So I want to find out where 80 equals 0.7x, right? Wait a minute. Yeah. Okay. There are no people on it, so we solved that.
Should be 113.286, right?
Okay. Yeah, well, I'll look at the rubric at that point. All right, now, so they like asking that. Now, part D, they really like to ask, and I want to make sure we know how to deal with this. So for part D, I shouldn't have erased what I had before. For 0 to 300, at what time is the number of people in line a minimum? And to the nearest whole number, find the number of people in line at this time. Justify your answer. We're going to make a chart. And so in our chart, okay, I'm going to start out with my chart. Here's time, and I'm just going to call that people. And we're going to start with time 0, and we're going to start with time 300. And we know at time 0 there are 20, and we know at time 300, was it 80? And what are we interested, and we need our critical values. What are our critical values going to be?
With derivative 0.
All right, when the derivatives are 0, right?
So you take
Or when the rates, the combined rates equal 0. So what I'm interested in is, and this is where I talked about it yesterday, was when the rate entering is the same as the rate leaving. Okay, and kind of the logic is we want to make sure, we want to know when our derivative is 0. Can we agree that the rate is derivative? And like our combined rate is, this is the rate entering minus the rate leaving. I want to know when that's 0. Because I'm looking for my critical values. And so I need to find out where R of t is equal to 0.7. How do we do that?
shove it into a calculator.
You graph stuff.
So you graph R2, you graph 0.7, you find the intercept.
Mm-hmm.
But that's like really hard.
Let's see how hard that is.
Oh, never mind, that's not hard at all.
Okay. So we're going to graph 0.7 of, all right, since we're measuring from 0 to 300, I probably want to change my window to go from 0 to 300. We may have to change our y value. I've already done this one. I think the y value of 5 actually works for this. So there's R of t, and there's our 0.7. And so we've got to find out these intersection points. So if I'm going to find out these intersection points, then I'm going to do second calc. I'm going to look for an intersection point here. And so so one intersection point is going to be 166.5747. And then the other intersection point is going to be way over here. So I end up with 33.013298. Did everybody get those values? All right, now, we need to find the total number of people, right? And so how you find the total number of people is, we're going to have to use our calculator, but the total number of people is given by 20 plus the integral from 0 to one number of r of t minus 0.7 times x. Do you see how this gives me the total number of people at a certain time? We start with 20, we take the integral from 0 to whatever a certain time is, and that tells us how many people have entered. And if I do 0.7x, that tells me how many people have left. And so,
what was your y2?
0.7. Because I was looking for, I wanted to know where r of t is equal to 0.7. And so put this in y1, this is already in y1, so we put this in y2 and find intersection. Did this make sense? This idea of writing down total number of people equals where did you start, this and this is huge. Right? And so this is going to give me 3.8034, and this is going to give me 158.07. I think that's a 94. Do y'all understand how I get this number in the calculator? Or I'm going to plug this in for my x's. Right. And now that we have our chart, to the nearest whole number, find the number of people in line at this. Okay. So at what time t is the number of people in the minimum?
33.01.
And to the nearest whole number, find the number of people in line at this time. 4.
How do you find the y values for those? You plug it into that equation?
You have to plug it into this. All right, and this is, you have to include your start, how many people entered, and then how many people left. Okay, and this, we had to do something similar to this in 2019, but in previous years, it seems like every previous year they had something that involved this. All right, very quickly, because I think I barely have enough time to do the next one. I do want to look at the rubric just so you see it. Okay. Got this. You got 1 point for the integral, 1 point for the answer. Translation, if you just give the number, you don't get credit for this. For this one, notice you have, I set up 2 integrals, they do it all at once. Right now, I actually think it's safer to consider 2 integrals, so I do this. Based on part B, number is 80, and so it's 114 seconds after this or that. Notice they don't care if you round up. I actually think this was 414, 2.2859 or something, and so they don't care if you round. Part D, notice part D is worth 4 points. You get 1 point for setting your rate equal to 0. You get 1 point for figuring out 33.031. You get 1 point for the answers, right, which is this, and then you get 1 point for the justification, and this chart is the justification. They love that, they like seeing a chart when you're trying to find the absolute max or absolute min. All right.
How do you know that the right answer is the one that's 33 and not?
Because you're looking for the smallest value. Which one of these is the smallest?
The 33.
Well,
Yeah.
smallest y value.
Yeah.
Yes.
When you put like 33 and 166, what were you plugging them into?
This function. Because I needed to find out how many total people I had.
What was the final answer for you?
4. Okay. All right. So next, another very, very common thing. Particle moves along the x-axis given this velocity, and the particle is at position -5 at time 0. Find the acceleration of the particle at t equals 3. What do you do?
Take the integral.
What?
Take the derivative.
Take the derivative, all right? So you stuck this in y1, right? Does everybody know if this is in y1 how to use your calculator to find the derivative at a certain value?
Second calc,
Yeah.
dy dx.
Okay. So very quickly, and y'all can actually do that faster than I can. I think y'all can actually do it a lot faster than I can.
What do you do with your initial condition?
Use it for another part.
Okay.
Okay. So I'm going to type this in. That's going to give me, so alpha y equals, I like having a fraction, so I can keep track of what's on top and what's on the bottom. 10 sine 0.4x squared over x squared minus x plus 3. All right, so now I have, no, I lost it. Okay. So for part A, it says find the acceleration. So that means take the derivative and plug in 3. Here's what that looks like. You hit alpha window. We're going to take our derivative. So I have to do it with respect to x. I'm going to stick in y1. And I'm going to plug in 3, and I've got my answer. Yay. Did I do that right?
That's not bad.
You got that? Okay. Okay, Nick.
That,
Okay, now, part B. So A is v prime of 3. Part B, it says find the position. How do you find position? Say it louder. What?
Like where you start plus the integral.
where you start plus how far you traveled.
Where you start plus how far you traveled. Where did we start?
You started -5.
We started at -5. Okay, how do we come up with an expression of how far we traveled?
Integral from 0 to 3 of y1 dx.
Integral from 0 to 3 of, please write v of t.
T.
Don't put y1.
How do you get the dy dx after not like the derivative?
Second calc.
Well, alpha window, and then you just choose it.
Wait, but the in derivative one, you have to have like a value, and you just put nothing in there.
You have a value. You had to plug in 3.
I don't know.
See, look.
Yeah.
Do you see it?
Yeah.
Okay.
Second calc, 6, and then if you're trying to calculate a certain number, you just
That's a different thing.
press 3.
Like it only computes at a certain number.
That's a different thing.
Okay. So, let's see, what do we have? Where's my, so that's -5 plus alpha window, f int. I'm going from 0 to 3 of my function, which in this case is alpha 1, and make sure to put an x there. I think this usually takes the line to run. Is everybody okay with that? All right? Did everybody understand? Because I want to make sure everybody understands that. Okay. All right, next up. It says evaluate these two things and interpret the meaning. Okay, I know you know how to evaluate this. Does everybody know how to evaluate this in your calculator?
No.
This is easy to evaluate, right? I mean, it's pretty much what we just had, right? Do you know how to put the absolute values in? So let's practice putting the absolute values in. It's really tricky. Ready? No sarcasm at all in my voice. Okay. So here's how this is how you take the absolute value. So we're going to do integral. So we're going to do f int, so that's fine. We're going to go from 0 to 3.5, so that part's easy. Go in here. We need to put absolute value bars. Ready? Hit alpha. Window. What option looks like it might be absolute value?
Abs.
Ah, well, good job. And then it gives you the absolute value bars. Everybody get it? And now we can stick our y1 in there, right? And there's dx and press enter. Yeah, that takes a while.
3.737.
Yeah. And so this one's 3.737. And let's see, I'm going to go up, get this one. I'm going to cheat a little bit. Okay. And then hopefully this next part's easy. So you get those numbers, interpret the meaning of each of these. What does this mean? Say it.
The distance?
No.
Position.
Displacement?
Displacement. Okay.
You're not doing the minus with it.
What?
Or you're not doing the minus font with it.
No, because this doesn't, they don't care about where you are. They said compute this. This is, technical term is displacement. You can say displacement. It's how far from where you started. What does this represent?
Total distance traveled.
Total distance traveled. Okay. Okay. Part D, a second particle moves along the x-axis with position given by blah, so that's our position. At what time are the two particles moving at the same velocity? All right? So what do we do?
You have to graph it.
Well, eventually, but all right, what equation am I going to solve? If I want the same velocity.
That is its position, so you're going to solve.
Thank you. Are we okay that this is not, are we okay this is velocity?
Mhm.
Is this velocity? How do we get velocity? Take the derivative. And so what I'm interested in is v of t, which is this mess, equaling 2x minus 1. Is everybody understand? Yeah, plug both of them in, find out where they cross. Is everybody okay with that part?
So do we need to just give it the value or?
Yes. Second particle, when are they moving at the same velocity?
So would we have to put like v of t is equal to 2t minus 1?
Yes. They're looking for this and then the answer.
Okay.
And because I'd like to really start the third question. I know. Well, I said start, I'm not going to finish. But notice you get 1 point for this answer. You get 1 point for saying integral from 0 to 3. You get 1 point for using initial condition and 1 point for the answer. You get 1 point for the answers and you get 2 points, one for each of the interpretation. And then you get 1 point for setting the velocity equal to this. So actually saying this and then finding this part.
And what was the answer?
Can you go back up to part C? So when you get those two, are those two are your answers, or is there?
Well, then you have to tell what each of those mean. So you have to know that if it's just the integral, it's displacement, and if it's the absolute value, it's the total distance traveled. Are we right?
Yeah.
Okay, and I'm going to go ahead and stop.